Okay, this is sample problem 4.6. We're continuing our discussion of reduction oxidation reactions. Remember, this is redox. And this is a specific type of redox problem that we're going to look at. The reduction oxidation of metals and with each other when they react with each other. So predict which of the following reactions will occur, and for those that will occur, write the net ionic equation and indicate which element is oxidized and which is reduced. So A is iron, solid, Fe, plus platinum chloride, PtCl2, aqueous, converted to what? B is chromium reacting with gold 3 chloride in water, and C is Pb, which is lead, reacting with zinc nitrate dissolved in water. So let's try to take a look at this one. So what I'm going to do is I'm going to write down A, and this one's FeS plus PbCl2. And we're going to try to figure out to see if this will react with each other. It might react, might not. The key here is that the reaction for this type of process is a reaction between the metals. That's really what this whole topic is about. It's called the activity series. And let me show you what the activity series is. Table 4.6 activity series. This is a table that allows you to predict whether metals will react with each other, and if they will react with each other, what the products will be. Okay? So notice what it is. It's lithium, potassium, barium, calcium, sodium, a bunch of metals. The only non-metal on that list is hydrogen, but all the others are metals. It also shows what are called the oxidation half reactions. This shows what happens when the metal gets oxidized. Now, if you recall from the previous sample problem, 4.5, we said that essentially the oxidation number is a measure of essentially the charge of something. So a lithium plus, Li plus, has a charge of +1, whereas a barium +2 has a charge of +2. This is showing that if oxidation occurs, oxidation is a type of reaction where substance loses electrons, that essentially lithium will be converted into Li+, and potassium will get converted into K+, and so forth and so on. So these are the half reactions. It also shows you an order of increasing ease of oxidation, meaning the higher up an element is, the more easily it is oxidized. And notice oxidation is always the symbol for the metal, converted into the product is the charge, the cation, meaning it's lost electrons. Okay? So here's the logic behind this. If a metal is higher in the chart, it's more easily oxidized. So let's take a look at this example here. A, we have iron, and then we have lead chloride. Now here's the trick. Iron has the symbol Fe, but lead is actually an ion here. Remember, this is an ionic compound, a metal with a nonmetal, so it's +2, and then the chloride is -1. So it's really Pb +2. Now here's how you use the table. You look for those two metals. So notice lead is on the table, as is iron. The metal that is higher up is the one that'll get oxidized. So notice iron is higher up than lead. So if iron doesn't have a charge at the beginning, and here it doesn't, and it's higher up, then it will react with the other metal. So there's two requirements. One is, well, it's actually one requirement, which is the higher metal is neutral. And another way of putting that is the lower metal is positively charged. That's the requirement for the reaction to occur. So if we look at those two metals, iron and lead, the iron is the neutral one, and it's higher up. That means a reaction will take place. That has to be essentially those two criteria. The higher metal is neutral. So what do they get converted into? You just read off the table. The iron gets converted into Fe plus 2. It's on the right side of the equation. And then the lead does the opposite. It goes from the plus charge to the neutral. So it's just going to go to Fe plus 2 and lead. Now what about the chloride? What happens to the chloride? The chloride in these types of reactions is unreactive. It doesn't do anything. So it's going to maintain the same charge and everything that it had before. So what you can do is you can just say, look, we got two chlorides. The iron has a charge of plus 2, and each chloride is minus 1. So we'll just write it as FeCl2. And then you can do states of matter, solubility guidelines. The solubility guidelines of chloride is that chloride salts are generally soluble, so that's aqueous. And then if it's just a metal, it's going to be solid, with one exception, and that's mercury. Mercury is a liquid at room temperature, but all the other metals are solid at room temperature. Okay? Let's move on to number B. Let's try that one. Again, the one that's higher up has to be the one that's neutral as a pure metal, and then the one that's lower down is the one that's going to have the positive charge. If that criteria is met, then there will be a reaction. If it's not, there won't be a reaction. So let's take a look at B. So B says we've got chromium, and it's reacting with gold chloride, AuCl3. Okay? So let's see if the one that is higher up is neutral. Oops, sorry. Chromium, if you take a look, chromium, Cr, is higher up than gold. Gold is all the way at the bottom. Au is all the way at the bottom. So the one that's higher up needs to be neutral. Well, chromium is neutral. It has a charge of 0, so it's higher up, so it will react. So now we try to figure out what it's going to turn into. So you look for chromium. Well, chromium, when it's converted, will get converted to plus 3. And then the gold will just get turned right back into the element. So this would be chromium plus 3 and gold. Then we go through the charges. There's 3 chlorides here. Each one's minus 1. So now chromium's plus 3, so it needs 3 of them. So CrCl3, aqueous. And then the metal, with the exception of mercury, would be solid. And there you go. So there will be a reaction. So we could say, yes, reaction. Yes, reaction. The one that's higher up has got to be the one that starts off as neutral. So let's try C. I assume in 3 options they're going to give us one that doesn't react, but let's find out. This one says that lead is going to react with zinc nitrate. They're asking us, will it react with zinc nitrate? Okay, lead and zinc. So you look for lead. So lead and zinc. Zinc is higher. Is zinc the neutral one? Zinc is not the neutral one. Zinc is part of this compound, is plus 2. The neutral one is lead. So the one that's higher up is zinc, not lead. If lead were higher up, then there'd be a reaction, but since the neutral one is lower down, there's no reaction. It's that easy. Okay? You just have to remember this. The higher metal has to be neutral. If it's not, then there will not be a reaction.